Parent functions. You got two different types of parent functions. So the first one that you got, there we go. Okay, you've got the square root of x, and that one's going to look like this. You're starting at 0, 0, and then you're going off to the right. So for my domain for this guy, you're going to start here, which is 0, 0, and you're going to go from 0 to positive infinity. My range is talking about my y values. So you're starting from your lowest y, which is 0, and going to positive infinity. For my other parent function, we have the cubic root of x. So the cubic root of x. And that guy is going to look something like this. And I'm going to actually show you the graph. And if you're ever unsure of what the parent function looks like, you can always go into Desmos and you can graph it this way. If it'll work. Yeah. Okay, so again, if you're like, I don't remember how to graph these things, I don't know what they look like, use your graphing calculator, use Desmos to help you out. So that would be x to the 1/3. Okay. There we go. Okay, so it's going to be this kind of like swoop, right? So going back over here, it's going to look like this. So swoop. Okay. So for your domain for that one, it's always going to be negative infinity to positive infinity. And your range is also always going to be negative infinity to positive infinity. Okay. So if it ever has this little 3 in the little cubby hole right here, then it's always going to be negative infinity to positive infinity. And if you have questions, just type them in the chat box as we're going along. I am going to record this, so you can come back and view it at a later time if you need to. Okay? Alright, so identifying the domain and range. Identifying domain and range. So what you're going to do is the first thing is you're going to graph both of these and then draw the little sketch of it. Sketch means it doesn't have to be perfect. So if I'm taking the square root of x minus 2, I'm going to go in here and I'm going to say square root of x minus 2, and this is what the graph's going to pull up. Okay, so if I want to do the domain for this guy, I'm going to go from 2 to positive infinity. For my range, I'm going to go from my lowest y value, which is 0, and go to positive infinity. Okay, so everything's kind of centered around this dot right here. Okay, this tells me a lot about my domain and range. Coming back to the second one, it's the square root of x plus 1 plus 3. So I'm going to go back into Desmos. Square root of x plus 1 plus 3. And so this is my dot right here. So if I'm writing out the domain for this guy, I'm going to say from negative 1 to positive infinity. And my range is going to be from 3 to positive infinity. Okay. Questions on that? Again, we're utilizing that chat box if you do have questions. Okay. All right, so I want you to go ahead and take a moment and try these two, and then we're going to go over it. Okay, so we're going to take that first one, we're going to plug them in here. And we're going to get 2 square root -2 square root of x minus 4 minus 4. So x minus 4 minus 4. And we've got that negative out front as well. Okay, so for the domain for this one, we've got from 4 to positive infinity. So the domain for this one, we've got 4 to positive infinity. And for the range, we have -4. And it's going down to negative infinity. So we're going to have negative infinity to -4. Okay. Another way to write that range and that domain is to say x is bigger than or equal to 4. So another way to write it, over here, x is less than or equal to 4. Okay. This is just a different notation. It's kind of like a nickname. Like if your parents called you, you know, Joseph, but your name, or your parents call you Josh, but your name is Joseph. Or Joe instead of Joseph. Okay. Just a different way of writing it out. It's the same thing though. Okay. Going back to that other problem, we've got the square root of 25x minus 100 minus 2. So we've got the square root of 25 minus 100 minus 100 minus 2. Oh, nope, I did it right the first time. Minus 100. Okay. So if we have this graph and we do the domain, my domain starts from 4 and goes to positive infinity. My range is going from -2 to positive infinity. Okay. And if you want to see the other way to write it, it's down here on the answer key at the bottom. Okay, so this is the same thing as what I have right here. Okay. All right, so there's a couple of different things that I want to just kind of go over that aren't necessarily on this document, but I think are kind of important for you to be able to be successful on your test. So the first thing I want to talk about is if it ever says vertically compressed. If it says there's a transformation that happens, so let's say transformation that happens, and it says vertically compressed. And it says you have the parent function square root of x. If it says vertically compressed by a factor of 1/3 and moved down 1, right 2. And we're taking this as the parent function. Then I'm going to put that 1/3 out front. I'm going to move it 2 units to the right by subtracting 2, because remember, everything's opposite underneath that radical. And we want to move down 1, so we're going to go -1. This would be the new transformation. Okay. Questions on that one? Okay, there is one question that's like that on your test. Okay. Another thing that I want to mention is there's a lot of just kind of plug it in and check your solutions. But if something says find a no solution equation, that's going to be the one that has a square root equal to a negative number. Okay? So what I mean by that is, for instance, here's an example. If I have the square root of x plus 2 plus 14, and I set it equal to 0, the first thing that you have to do in order to solve for this guy is move this one over to the left, or to the right, right? So that's going to be the square root of x plus 2 equals negative 14. Well, can I ever have a positive square root equal to a negative number? No. So that's going to produce me a no solution result. Okay? Questions on those two things? Let's say, for instance, you have a graph, and the graph is talking about miles per hour versus time. Okay, and the graph goes like this. At this point and below, that's going to have negative miles per hour. But is that even possible? Can you go negative miles per hour? No. Okay, so once it hits this part, that means that it has an invalid miles per hour, right? Invalid. Okay, it doesn't make sense, it doesn't work. Okay. If I had, last week we started talking about literal equations, okay, and you did that delta math on literal equations. Okay, so if I have V equals I times R, and I said solve for I, what would you do first? We want to get I by itself, so we would divide by that R to get I by itself. Divide by R to get I by itself. And so that's going to give me I equals V divided by R. Okay, so with literal equations, you're just like rearranging the problem. Okay? Again, it's like moving around your bedroom furniture. Okay? We also talked about end behavior back in the day, which is as x is approaching positive infinity, y is approaching some value. As x is approaching negative infinity, y is approaching some value. So if I had a graph that looks like this, as x is going to the right, what's happening to my y? It's getting bigger. As x is going to the left, what's happening to my y? It's getting bigger. Okay? So end behavior is starting from that 0, 0 point and looking to the right and then looking to the left. Okay? The last thing that I want to mention is interval of increase or decrease. Okay? If I have a graph that looks like this, sorry, let me graph it better. If I have a graph that looks like this, obviously this is decreasing, right? It's going down. Okay? Now the question is, where is it going down? Well, the entire time it's decreasing. So my interval of decrease would be from negative infinity to positive infinity. Okay? And also, just as a reminder, there are videos down here at the bottom if you missed a day or if you need to go back and look at something. There are also videos down here on that e-class page. Okay?